Right, so this is the problem we need to solve. Now, let's first define a system. So let's say a system is the block of ice plus the surface on which it slides plus the earth, which provides us with the weight. So the gravitational pull from the earth on this block is essentially the force that would be moving it over the surface. And what we need to calculate is what will that velocity be once the block gets over there. So if this is our system, we can say two things. All the forces that are doing work are internal. Right? Because the only forces this block experiences is its weight and a normal force from the surface. The normal force cannot do any work anyway because it's always perpendicular to the surface. The weight will have a non-zero component parallel to the surface, and that is what will be doing work throughout. But both those forces are internal, and both those forces, or forces doing work in this case, are also conservative. And there are no other external forces, so our system is isolated. So there's no external force doing work. Sorry, keep getting shifted. So we can say this, we can say that, and we now know for isolated systems where we've got conservative internal forces, we can say that the change in mechanical energy, which is equals to the change in kinetic energy plus the change in potential energy, will be zero. So at every point, if I add up the kinetic energy of the system and the potential energy of the system, I must get the same number. So let's look at the initial potential energy of the system. Now, as before, this surface is probably connected to the earth through some bolts and screws. So the earth plus surface is so massive that it cannot really be accelerated in this motion, so it doesn't gain kinetic energy. Again, therefore it cannot have any potential energy. So the only kinetic energy and potential energy inside the system is the kinetic and potential energy of the block. So the initial potential energy of this block is just its mass times gravitational acceleration times the height. This is 2 kilograms times 9.8 meters per second squared times 3 meters. And the answer that you should get if you calculate that is 58.8, yes. Now it's also got an initial kinetic energy. This is equals to a half times the mass of the block, which is 2 kilograms, times its speed squared. This is just equals to 1 joule. So that's the initial potential, initial kinetic energy of the system. The final potential energy is equals to 0 because the height of the block there is 0. It cannot move any lower. So here its potential energy will be a minimum, and we can say effectively that means it's 0. So the final kinetic energy of the system is now what we need. But we know because of this, we can say that the change in kinetic energy, so K final minus K initial, plus the change in potential energy, so potential energy final minus potential energy initial, has to be equals to 0. Right? Change in kinetic energy plus change in potential energy must add up to 0. We've got numbers for this. We don't know what K final is, but we know K initial was 1 joule, plus we know the final potential energy is 0 minus whatever the initial potential energy was, 58.8 joules. This must all be equals to 0. Therefore, K final is equals to 59.1 joules. From this, we can calculate the final velocity. 59.8, sorry. From this, we can calculate the final velocity. We know that this must be equals to a half times 2 kilograms times the final velocity, speed squared. And if you do the calculation, you should find that the final speed is equals to 7.73 meters per second. Right, I think